Hello and welcome to my channel. In this video we will solve problem 3 and 4 of miscellaneous exercise on chapter 14 in 11th class maths. The third problem is a die has two faces each with number 1, three faces each with number 2 and one face with number 3. If die is rolled once, determine first probability of getting 2, second probability 1 or 3, third probability not 3. So what is given is a die which has faces and two faces each has number 1, three faces each has number 2 and one face has number 3. Now if the die is rolled once, we have to determine what is the probability of getting 2, then we have to determine what is the probability of getting 1 or 3, and third we have to determine the probability of getting not 3. So let us solve this problem. So solution. Now let us write what is given to us. Given a die has two faces each with number 1, three faces each with number 3 with number 2, three faces each with number 2 and one face with number 3. Okay. Now we have to look at what is the sample space here. So let S be the event of getting a number on the die. Okay, this is the sample space, that is the event of getting a number on the die. Now let us go to the first sub problem, that is we have to find probability of getting 2. So first, now let E be the event of getting number 2 on the die. Okay, so how many elements will be there in the set E? Let us see. Number of elements in set E will be, so we have to look at the faces, how many faces are there with number 2. So there are three faces each with number 2, right? So that means from the three faces with number 2 we have to one number is selected, so that is 1, right? So 3C1 will be there, right? And if you look at the number of elements in sample space, how many will be there? So we can select one number from the total 6 faces, right? Because 2 plus 3 plus 1, that is 6. So from the 6 we are selecting one number, or we are getting one number, so 6C1, right? And here we are selecting from the total 3 number 2s, one number 2 we are selecting. Okay, so now let us find out the probability of getting the event E. So probability of getting event E is equal to number of elements in the event E and number of elements in the sample space. So that means we will get 6C1, sorry, n of 3, right? So 3C1 divided by 6C1. So that is nothing but 3C1, you know, we don't have to use the formula here, we know it directly. It is 3 and 6 C1 is 6. So this is equal to half. Now let us go to the next sub problem, that is second one. So now we have to find what is the probability of getting 1 or 3. So let us take the event f. Let f be the event of getting number 1 or 3. Okay, so that means number of elements in the set F will be what? So we have to look at how many faces are there with number 1. So there are 2 faces with number 1. So from that we have to, or we get 1, right? Or means plus here. The die can also show number 3 here. So that means we have to look at the faces with number 3. So there are only one face with number 3. So that means 1 C1 we will get. So this is equal to 2 C1 is 2 plus 1 C1 is 1, that is equal to 3. So that means probability of F will be equal to number of elements in F divided by number of elements in S. So that is equal to 3, right? Number of elements in F is 3 divided by number of elements in S is 6 C1. So that means 3 by 6, which is equal to half. Okay, now let us go to the next sub problem. So that is the third one. And what is the probability of getting not 3? So first of all, let us consider the event G here. So let G be the event of getting number 3. Okay, getting number 3. So how many elements will be there in the set G? Now since there is only one face with number 3, we can get, or the number of ways of getting 3 on the face is 1 C1. So that is nothing but 1. So now we have to find the probability of not G. Okay, so probability of not 3, because we have to find, so we have to find probability of not G. So that is equal to 1 minus probability of G. So this is equal to 1 minus probability of G will be number of elements in G divided by number of elements in S. So this is equal to 1 minus number of elements in G is 1 divided by number of elements in S is 6 C1. So this is equal to 1 minus 1 by 6. So that is nothing but 6 minus 1 by 6, which is equal to 5 by 6. Okay, so this is the answer of the third sub problem. So we have solved the problem. Now let us go to the next problem, that is this fourth one. In a certain lottery, 10,000 tickets are sold and 10 equal prizes are awarded. What is the probability of getting a prize if you buy A 1 ticket, B 2 tickets, C 10 tickets? So what is given is a lottery in which there are 10,000 tickets, and this 10,000 tickets are sold and there are 10 equal prizes. Okay, now we have to find the probability of not getting a prize if we buy 1 ticket, 2 tickets and then 10 tickets. So let us solve this problem. Solution. So that is, we are finding first the A. Now let us consider the sample space first. So let S1 be the event of selecting 1 ticket. Okay, so therefore the number of elements in S1 will be what? See, there are 10,000 total tickets, so from that we are selecting one ticket, so that is 10,000 C1 number of elements in S1, because we can choose the tickets in 10,000 C1 ways. Okay, so this is the number of elements in S1. Now let us consider E1 here. So let E1 be the event of not getting a prize, okay, by buying one ticket. Okay, so now we have to find the number of elements in E1. So number of elements in E1 will be what? Now you can see that there are 10,000 tickets, right, and there are only 10 tickets which match with the lottery tickets. Okay, so that means we have to remove these 10 tickets, because we have to find the event of not getting a prize. So we have to remove the 10 tickets from the 10,000 here. So that means 10,000 minus 10 will be 9,990, right? So from this 9,990 we are selecting one ticket. So 9,990 C1, right? This is the number of elements in E1. So therefore now we can find the probability of not getting a prize if you buy a one ticket. So probability of E1 is equal to n E1 divided by n S1. So this is equal to what? 9,990 C1 divided by 10,000 C1. So that is equal to, we know 9,990 C1 will be 9,990 and 10,000 C1 will be 10,000. So 1 0 will get cancelled here, right? So that is 999 divided by 1000. This is the probability. Now let us find the probability, the second probability. Now here we have to find the probability of not getting a prize if you buy two tickets. So now the sample space will be different. So let S2 be the event of selecting two tickets, okay, from the lottery which has total 10,000 tickets. So that means NS2 will be equal to 10,000 C2, right? Now let us consider the event E2. So let E2 be the event of not getting a prize by selecting two tickets. Okay, so that means NE2 will be what? Now there are 9,990 tickets which do not match the 10 tickets. Okay, now from that we are selecting two tickets. So 9,990 C2, right? So that means therefore the probability of E2 is equal to n E2 divided by n S2, right? So that is equal to what? 9,990 C2 divided by 10,000 C2, right? So that is the answer of the second sub problem. Now let us go to the third sub problem. So again the sample space will change here. Now we have to find the probability of not getting a prize if 10 tickets are bought. Okay, so let S3 be the event of selecting 10 tickets. Okay, so number of elements in S3 will be what? So 10,000 C10, right? Now let E3 be the event of not getting a prize by selecting 10 tickets. So that means number of elements in E3 will be what? So it is equal to 10,000 C, not 10,000, sorry. So we have to select the 10 tickets from the tickets which are not matching with the 10 lottery tickets. So that means 9,990 C10, right? So therefore probability of E3 is equal to n E3 divided by n S3. So this is equal to what? So n E3 is nothing but 9,990 C10 divided by n S3 is 10,000 C10. Okay, so this is the answer. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.